All right, ladies and gentlemen, as we talk about our geometry as a system, let's continue building. Now, every building needs a couple building blocks, and the basic building blocks of our geometric system that we're going to work in the Euclidean system is going to be using undefined terms. Now, undefined terms are terms that literally have no definition. They can't be broken down any smaller than they're already broken down. You can tell me where a point is. You can tell me that a point is a location, but graphically, a point is the basis of everything we build. Now, we already talked about if I string a whole bunch of those points together, and in fact, if I string them together infinitely in each direction, I come up with a line. So one point is used to build, or multiple points are used to build a line. And that line goes through A and it goes through B, but it keeps on trucking on to infinity. If, on the other hand, I take a number of these lines and I put those lines right next to each other, and I start putting lines together, I get this thing that looks a lot like this. And we call it a plane. So a point, a line, and a plane are undefined terms. Now, let me give you an example of that. I have a kitchen towel, all right? If I take a look at this kitchen towel, you would agree this is a plane. I can flatten it out, lay it here. It is a perfectly wonderful plane. But you'll also notice within this plane, because of the way it's manufactured, you can see definitive lines running through the plane. But if I zoom in even closer, you'll see that those lines are not actually continuous lines. They are individual little loops of thread that have been popped up and popped through. So each one of these is an individual loop, but those loops put together create lines. Those lines, when you line them up together, create planes. And that's the idea of the process we're using here, is we're creating a two-dimensional space out of a series of points for the purpose of creating planes. Now, those undefined terms are important because then if I put a few more pieces of information between them, if I have points, but they only go from one place to another place, now they're called a line segment. And if I take those points and I start one place, but now I go infinitely in only one direction from A to B, I have a ray. So I have point, line segment, line segment, ray, and plane. You'll notice the path here is we're just adding pieces, adding pieces, adding pieces, and growing. This, if this has a label A, this is going to be called point A. And that's how we label it. A line segment is going to be any 2 points on that line listed with a segment above them. Now, they have to be 2 points on the line. In fact, on the line is the definition of collinear. Linear meaning line, co meaning with, on the same line. Now, for a ray, since it goes infinitely in one direction, we're going to say A, B, and we're going to put an arrow at one end. But it's important that whatever your initial point is your first point, and what it goes through but does not stop at is your terminal point, and your ray is listed in that direction. So I could list this as ray AB, but I could not list it as BA. However, a line, since it goes infinitely in both directions, it's still AB because they're collinear points, but it goes infinitely in each direction, and I put an arrow on each end. Now, for a plane, I'm going to have at least 3 points. Now, sometimes we use 4, but we have to have at least 3 points, and those 3 points have to be non-collinear. Non meaning not collinear, not on the same line. So, for example, if I have A to B to C, and they're all on the same line, that's collinear. But if I have A, B, and C, I now cannot draw a single line through all 3 points. That would be non-collinear, not on the same line. Okay, so with our undefined terms, we can flesh that out a little bit with a few more terms, and now we have the idea of beginning to build a system of geometry.